In this video, you'll learn how to use Place on Surface to dynamically place objects on terrains and colliders. To get started, let's open the included tutorial scene. For this example, we'll be placing the red pyramid object. This model is oriented upside down with its anchor at the tip of the pyramid, which will help us to visualize the placement. We can add this object to the Timeflow view by selecting it and pressing Alt-tilde. Then right-click the object to add automation, Place on Surface. This creates two new channels, Placed Position and Placed Rotation, and we can go over further settings in the inspector. The default mode uses sample terrain height, which can be used to place objects on any number of terrains in the scene. If you only need to place objects on terrains without rotation, then this method is optimal. However, to place objects both on terrains and other surfaces requires the raycast mode. For this example, we'll use raycast. This works by sending a raycast through the scene, typically straight down vertically, to the first surface hit. In order for surfaces to be detected, they must have a collider component. In the scene view, this is visualized with a gizmo line displayed in the same color as the channel, with a yellow dot showing the position hit on the surface. We can then move the object to another location and press the refresh button to update the object placement. If the Timeflow view is playing, it updates automatically each frame whenever the object is moved. If you wish to manually control the update rather than it happening automatically, you could go into the update settings and set the update mode to explicit. When this mode is selected, the behavior only updates when the refresh button is pressed. And clicking Refresh All updates all instances of Place on Surface in the scene. This may be useful when using Place on Surface to create layouts. For this example, though, we want to animate the object, so let's click Restore Default Update Settings to revert the update mode back to every frame. Back at the top, we'll go over more of the settings. The first drop-down menu sets the layer mask, determining which surfaces may be used for placement. Using this menu, you can select any combination of layers to include or exclude, though for now, we can leave it at default. However, a warning is displayed, since the object being placed is on the same layer as the surfaces being placed on. If the object has a collider, it could interfere with raycasting and result in the object placing on itself, causing anomalous behavior. To avoid this, we need to select a different layer for the object, such as Ignore Raycast, or any other layer which isn't included in the Place on Surface layer mask. And once the layer has been changed, the warning goes away. The raycast direction sets the vector angle of the ray as a normalized value, adding up to 1. This is typically set to -1 on the y-axis, so that the ray is cast directly downward, though it may be adjusted to project the ray at an oblique or sideways angle. If Use Transform is enabled, the raycast is oriented towards the target object. For example, we can assign the sphere. Then no matter where the object is positioned, it raycasts towards the sphere. This can be helpful to make an object follow the contours of another object from any direction, though it is still placed on the first surface hit by the ray. The offset shifts the starting point of the raycast relative to the object, optionally including the terrain height automatically. This ensures that the ray is started well above the terrain and any other surfaces so that they can be hit by the raycast. Otherwise, it might start under the surfaces and miss them altogether. The raycast distance determines how far away surfaces can be detected, indicated by the line drawn in the scene view. The distance should be set according to the scale of your scene. For this example, we can turn off Use Transform and reset the raycast direction back to the default -1 on the y-axis. Next, we have the object we are applying placement to. Presently, this is the same object the behavior is applied to. However, in some cases it may be helpful to apply placement on a separate object so that the placed position doesn't affect the origin point of the Place on Surface behavior. We can leave it as it is for now, but if you'd like to see a working example of this setup, see the Place on Surface example scene. If Use Rigid Body is enabled, position and rotation are applied using physics so that the object may interact with other rigid bodies and colliders. Let's now set up some animation on the object to demonstrate live placement. Any behavior could be used, but as a quick example, we'll right-click on the object in the Timeflow view to add automation Flyby. And then in the scene view, we can use the transform handle to position the path over the terrain. One important thing to note is that the channel order matters, since we want Flyby to process before Place on Surface. So if you are not seeing placement on the terrain, try reordering the channels by dragging and dropping flyby after placed position. Or you can go into the update settings for Place on Surface and set it to late update. Now that we have some animation to work with, let's go over the remaining settings. Both position and rotation may be enabled separately. Rotation is only available when using raycast mode. Note that the placed position channel is displayed in the Timeflow view regardless if position is enabled or not, since it is the base channel for the behavior. However, the placed rotation channel is only displayed when rotation is enabled. Position can be applied to all axes, or you may uncheck each axis you wish to remain unaffected. Sometimes when placing objects on surfaces, it is helpful to place the object on the y-axis only. Both position and rotation have a smooth time setting to apply temporal smoothing defined in seconds. When smoothing is applied, it blends the movement over time, though using a larger value may cause noticeable lag. This option is best to use with objects that hover some distance off the terrain, otherwise it can cause objects to pass through surfaces when moving. For best results, use a small value under 1 second. To make an object hover above or lower than the surface, use the height offset. This shifts the object in the direction of the raycast or vertically when using the sample terrain height mode. If you wish to constrain an object movement, world limits may be enabled for each axis. This defines a minimum and maximum value in world coordinates, restricting the final object placement. When rotation is enabled, the face surface hit option rotates the object to look at the surface point hit by the raycast. This is useful when projecting objects onto surfaces. Otherwise, if this option is off, then the object rotation matches the surface normal hit by the raycast. And as we have seen with other behaviors, the orientation applies a relative rotation to the object, which can be used to orient the object or add additional rotation. And finally, we have the display options to show or hide the gizmos in the scene view. If debug ray is enabled, each raycast is drawn in the scene view, showing the result of each. This can be helpful to troubleshoot issues to see more clearly which surfaces are being hit. One final tip: if you wish to optimize Place on Surface when using raycast mode, you can set the update mode to fixed update. This also requires setting fixed update for the flyby behavior to function properly. Using fixed update reduces the frame rate at which raycasts are calculated to improve performance. This is based on the fixed time step value set in the project settings under time. That concludes this video on using Place on Surface. Please refer to the documentation links in the video description below for more information. Next up, we'll go over using Timeflow events.